To our software engineering analysis and design lecture series. So today we shall be continuing and look at design as problem solving. Whenever you need to solve a problem, one of the critical activity of the planning stage is design. So design is a problem solving tool. So it means that we can partition information between the problem and solution. And since there are many valid solutions and we cannot, don't want to waste time and resources to implement several solutions, we want to use design to be able to evaluate the pros and cons of many solutions. So we can apply general problem solving techniques like changing the problem, brainstorming, some try and error, and dividing the problem into various modules and solving them um, separately, then combining the solution of the several modules into one single unit solution. So another concept in software engineering and design and analysis is abstraction. Abstraction is one of the key concepts used in software design. What is the advantage of abstraction? You don't capture all the details. You look at the eye level. You approach the problem at the eye level. That helps to simplify the problem, and you focus on the important aspect and ignore details. Then it allow you to structure the problem and decompose the problem from a top-down approach, looking at the um, holistic approach to the problem from top down. Then you can focus on the detail when required. Modeling is another important concept. So a model is an entity used to represent another entity. Technically, I see model in software engineering as drawings, as designs, stand to be corrected. So before you actually implement the software, you want to have a kind of a drawing of how things are going to relate or interconnect, and what are the components that are going to form your system, your software system. So by establishing between the element of the target and the element of the model, so uh, the real system that you want to model, you want to look at the component that are essential and make sure they are captured in your model. Then the corresponding between relationship among element in the target and relationship among element in the model. Your target is your software system in our case, and the model are your diagrams or your designs that you're trying to use to capture your software system, and you want to see how things flow. So, for instance, this is an example. Uh, what are the elements of the model, and then what are the relationships in the model, and how is the model similar and different from the target? So, let's say you want to build uh, a boat or a ship. You may want to do a little design of some of the components that make up your boat. So why models? It's essential for problem understanding. It helps us to be able to understand the problem in a deeper level so that we know what we are really dealing with. Two, it assists in designing mm, design creation and investigation. That is, when we need to now begin to draw out a layout, so the models allow us to try without building complete solutions and to investigate various approach of solving the same problem. And it's also helpful in documenting the design. So software design models, they are used to model static and dynamic behaviors of the software system. And static are the component of the software system that are rarely changing. Dynamic are, are the part that are obviously constantly changing. So the static represent those that do not change, and the dynamic represent what happens during program execution. Take for instance, you are building an ATM machine. So what state should the ATM machine be at the time that the user is coming to insert the credit card? And after the user has inserted the credit card, what state should the machine transit to? So all these are dynamic, these are things that are changing. So, and what are the different types of design? And that is where we're going to continue in the next lecture. Thank you for listening, and see you in the next one.